All right, now into 3.2a. I'm going to break up section 3.2 into two different lessons here, two different days. And now we're getting into identifying the number of solutions. Okay? Don't necessarily write this down, but let me kind of cut right to the chase and get us started on a good foot here. Let's say I wanted you to solve an equation like x plus 7 equals 10, right? And you'd be looking to just get x by itself, and you would end up with x equals 3. So that's the solution. So how many solutions is that? And that might be a little bit of a weird question to you at this point in time, but because you're thinking like, wait, what? It's the answer, like the answer, the one and only answer is 3, And so, like, yeah, in that situation, there is only one solution. All right? So if you end up getting like x equals some number, like x equals 3, x equals negative 2, x equals 157.2, I mean, whatever. If you end up with like, and this is the normal situation. This is the situation that's going to happen like almost every time you get x by itself and you get like x equals some number. And yeah, like there'll be one and only one solution, in that situation. But there's other situations that can happen. If you end up with a false statement, and you'll see what I mean shortly, that means there's actually 0 solutions. There's no solution at all. That's possible. That is possible. If there can be no solution at all. And if you end up with like a true statement, and you'll see what that means shortly, there's actually an infinite number of solutions. There's infinity solutions. There's an endless number of solutions. So that's another situation that can happen. Now, as far as these pictures go, these two lines that are parallel, these two lines that intersect, these two lines that are really just the same line over top of each other, these pictures have connections, two lines that are parallel. There's a connection here. It doesn't, we're not really getting to that yet. Like that's going to come later on. But we might as well introduce you, plant kind of a seed, or at least a little bit of foreshadowing. This picture will definitely have more meaning to us later on, like in a later chapter. But yeah, like for right now, I'm going to emphasize this, right, way more than the picture. So a false statement means that there's 0 solutions. And what that means really quick is that two lines that are parallel have like 0 points in common. They don't intersect at all there, okay? And then two lines, again, I'm going to emphasize this way more, but, two lines that intersect share how many points in common? They share 1 point in common, right? And then over here, it's really mostly about this right now, but, if two lines are actually the same line, then they share an infinite number of points in common. So I don't know if that'll help you remember for now. We're not really going to be seeing these pictures like at all, except on maybe a quiz or on the test, but these will come into play in later chapters. Not so much right now. They won't really matter. So here we go. Let's see this in action. Well, let's solve these equations by doing the same stuff we've been doing for so long. distribute the 5, and 5 times x is 5x. 5 times 3 is 15, and we bring down the other side, and now we see that there is an x on both sides. We don't want an x on both sides, so we do this, and we also have to do it to the other side, and oh, wait a second. What's happening here? 5x minus 5x, that is also canceling out to be basically 0. So my x variable is totally gone. And my left side is now just 15, and my right side is now just 3. And so now my equation says 15 equals 3. Does 15 equal 3? No. That is a dirty, stinking lie. And that's what I mean by ending up with a false statement. You know, when there's no x left over to equal anything, we just have like this number equals this other number, and it's either true or it's false. 15 does not equal 3, liar. And so the final answer is no solution at all. That's how that works out. What happens over here? So we have to distribute and get 3 times x minus 3 times 4, which is 12. Looks like we also over here. And so 2 times x is 2x. 2 times minus 1 is minus 2. We don't want x's on both sides, so I'm going to move that out of there. All right, so 3x minus 2x is 1x, just x. And this is turning out more normal, right? Where we have an x that we can get all by itself. All we got to do left over is just have x equals, what's negative 2 plus 12? 10. And so that is going to be one solution. One solution, which is 10. The one solution is x equals 10. Another example. Well, what do we do first here? There's no parentheses to clear, but I see a couple terms that are alike that are already on the same side as each other. So you just combine them as is. X plus 2x is 3x. Last time I checked. And now we end up with the left side of 3x plus 5, and the right side now is 3x plus 5. That's, well, let's just keep, so let's get the, look at that. So the x's are totally gone, right? Because again, like 3x minus 3x is technically 0. So we just have 5 on the right, 5 on the left, and also 5 on the right. So the x's are totally gone. So what's left is either true or it's false. Does 5 equal 5? Yes, that is completely true. And so that means there is an infinite solutions. And to be maybe even a little more specific, I guess, all real numbers are solutions. I could plug in any real number I want to, any number I can think of, really. Well, because all you'd probably think of is real numbers. But all numbers, all real numbers make that true. I could plug in negative 2 for the x's and it'll be true. I could plug in 50 for all those x's and it would make it all true. I could plug in negative 25 million. I could plug in 7.382105. Doesn't matter. That's what that really means. Any real number will make that true. I mean, at least in this situation, when I say that there's infinite number of solutions. Let's do maybe one more. I hope at this point in time you know what needs to be done first. Clear the bubbles by distributing what's directly out in front being multiplied to it. So the 7x minus 10 just comes on down. 3 times x is 3x. That's all I can write. 3 times negative 2 is minus 6. Positive 4, okay? Positive 4 times x is positive 4x. Positive 4 times negative 1 is minus 4. And now I think, I got to be careful not to write too big here. I might run out of room. But over here I see that 3x plus 4x is 7x. And negative 6, that's not just a 6, that's a negative 6. Negative 6 minus 4 is minus 10. Negative 6 minus 4 is negative 10. And I mean, I can already tell what the final result's going to be, but let's let this play out. Let's get the x's on one side. Nope, they canceled out on both sides. So what's left is negative 10 equals negative 10, which is either true or it's false. In this case, it's true. Yeah? And that means that there is an infinite, I'll just write infinite solutions to that guy. And that does it for 3.2 Part A.